Skibidi, Riz, Guyat, Phantom Tax. If you've spent any time around teenagers lately, or even just scrolled through a comment section, you've likely encountered this specific string of nonsense. But this isn't just a playground trend. These terms have entered our official institutional records. Oxford University Press recently added brainrot to its lexicon, naming it the 2024 Word of the Year. Formally, it refers to the consumption of low-value digital content that leads to a decline in cognitive function, that feeling of mental fog and restlessness that follows hours of mindless scrolling. While the term sounds like a cultural joke, it is a surprisingly literal way to describe a shift in how our minds are functioning. It points to a change in our focus that we are only beginning to understand. The most visible evidence of this shift is found in the generation born into a digital-first world. From toddlerhood, tablets and smartphones are fixed in their hands, acting as high-tech pacifiers that keep them perfectly mesmerized. The fallout happens the moment that stimulus is removed. Parents report that children as young as 3 are displaying levels of aggression and violent meltdowns that occur the second the screen is turned off. Beyond behavior, pediatricians are identifying developmental delays at the highest rates ever recorded. A significant number of toddlers are reaching school age while remaining nonverbal, preferring digital pixels to human speech. In the classroom, the academic results are stark. Educators report that many 7th grade students are currently reading and performing at a 4th grade comprehension level. The label screen addiction fails to capture the scale of this change. This constant high-speed stimulation is altering the foundational systems children use to learn and regulate their emotions. To understand why this is happening, we have to look at our original biological hardware. For hundreds of thousands of years, the hunter-gatherer brain evolved to scan its environment for survival, paying attention to what matters and filtering out noise. When an early human spotted a source of food or a potential predator, the brain released dopamine. This chemical reward signaled that the information was novel and vital, telling the body to pay strict attention. Our brains still use that same survival circuitry today, but instead of occasional alerts in the wild, our synapses are now continuously flooded with dopamine hits from every notification and scrolling video. Our neurology has a specific flaw. It cannot tell the difference between a survival cue and a meaningless video clip. Both provide novelty and both trigger the exact same ancient reward system. This creates a cognitive evolutionary mismatch. Our ancient hardware has been hijacked by a digital environment that keeps us in a relentless, exhausting cycle of seeking rewards that don't actually exist. This problem was anticipated in the 1960s by Marshall McLuhan, who famously observed that the medium is the message. He argued that the way we communicate shapes our thinking more than the information being communicated. Today's platforms prove his theory. Algorithms are designed to prioritize shock value and instant gratification, conditioning our brains to expect a reward every few seconds. This diagram shows the pacing of modern children's content. The video is fractured into aggressive jump cuts every 1 to 3 seconds, paired with saturated colors. This rapid pace denies the brain time to process, creating constant sensory overload that overwhelms developing cognitive systems. The underlying message isn't the story in the video. It is the pacing itself. It is a biological conditioning that trains the brain to demand immediate, endless stimulation. We are able to adapt because of neuroplasticity, the brain's ability to physically rewire itself based on its environment. Our neural pathways are constantly being built or pruned depending on what we do. Historically, this rewiring was a slow process, but around 2007, with the smartphone revolution, that adaptation went into hyperdrive. We began exposing our brains to a level of novelty they were never designed to handle. When we interrupt our focus every few minutes to check a feed, we prevent the hippocampus from turning short-term information into long-term memories. We are training our brains to stay on the surface. In less than 2 decades, we have used neuroplasticity against ourselves. We have physically fragmented our attention, making the act of sustained, deep thought feel increasingly unnatural. This fragmentation has personal costs. Mental health professionals are seeing a generation struggling with increased anxiety and a complete inability to sit with boredom. This loss of focus has consequences for our collective progress. Complex problem solving is built on deep work, extended periods of uninterrupted thought. If our ability to concentrate erodes, so does our ability to solve the technical and logistical challenges a society faces. There is a solution rooted in the same biology that got us here. Because neuroplasticity works both ways, the brain can be trained back to its original state of focus. This requires progressive overload for your attention. Think of focus as a muscle. You start with 5 minutes of reading without distraction and slowly increase that time, rebuilding your mental endurance day by day. You also have to change your environmental design. By adding friction, like putting your phone in another room or using website blockers, you make distraction difficult and allow focus to become the path of least resistance. Finally, you have to allow for a dopamine reset. This means intentionally sitting with boredom and removing stimuli so your brain can return to a baseline where normal, slower activities feel rewarding again. Here is the final challenge. When this video ends, do not click another thumbnail. Sit in silence for 60 seconds. Reclaim that minute of your attention and prove you can beat the scroll.